You are welcome back to mathematics class. Today we are going to be looking at transpose of matrices. Alright, so let's begin. If A is a matrix and is given as A, B, C and D, okay, so the transpose of A is given to be equal to, okay, so in transpose matrix what we actually do is that we change the rows to column, okay, and the column they becomes row. That's what actually happened. Okay, so look at this A and C, they are what? They are column. Okay, so I'm going to change them to what? To row. It become A, C, and then this second column 2 will become the second row. Is that okay? So I have B, D. So this is how to do transpose, okay, of a matrix. Now transpose can also be denoted as A. For example, this transpose A could be shortened as A raised to power T. Is that understood? All right, let's take some examples. Okay, so example number 1. The question says if A is given to be 5, 6, 7 and then 8, then find A transpose. So find the transpose of A. Solution. So we don't need any calculation here, just to change the rows to column and then the column to row. So therefore A transpose will be equal to, so this row now 5, 6 will become column. So I have 5, 6. Okay, then this second row 7, 8 will become the second column, okay, which is going to be 7, 8. So and that is the transpose of that question. Is that understood? Well, let me give you another question. Let me rule it out like this. Number 2. So find transpose of C if C is equal to 0, 1, 4, 7, 10, 12, and then we have 3, 5, 16. Okay, so C transpose, so the transpose of C will be equal to, so all this row now, the first row, all this first row will become column here, and that will be 0, 1, 4. Then the second row will become the second column here, which is 7, 10, 12. And then this third row will become the third column, which is 3, 5, 16. So and that is the answer to that question. So as simple as that. That's how transpose are being carried out. Well, let me give you one more question under this transpose, and that will be number 3. The question says, given that A is equal to this minus 2, 4, 1 and minus 6, okay, obtain A plus A transpose, then you find the transpose of everything. Okay, solution. So now let's first of all find the A transpose. A transpose will be equal to, so this A given to us is transpose will become all these rows. The first row will become the first column, which is minus 2 and 4. Then the second row will become the second column, which is 1 and minus 6. So that is our A transpose. Then we will now find A plus A transpose. So A plus A transpose will be equal to, A is given as minus 2, 4, 1 and minus 6. Then plus A transpose, which is giving us -2, 1, 4, and -6. Now this is addition of matrices that we have learned in the past. So doing that, we have -2 plus -2. That will give us what? -4. Then 4 plus 1, that will be 5. So 1 plus 4, that will be 5 also. Then -6 plus -6, that will be -12. So this is A plus A transpose. Understood? So let's continue. We now want to find the transpose of A plus A transpose. Okay, what will be the transpose of this answer here that we got? The transpose of this answer will become the first row will become the first column here, which is -4 and 5. Then the second row will become the second column here, which is 5 and -12. Understood? So, and this is our final answer for this question. So this is how to solve problems on transpose of matrices, as simple as you have understood it. Okay, so let's continue. Now I want us to look at the inverse of matrices. Okay, the inverse of matrix. So that's what we are going to be looking at next, and this is also very simple. All right, so let's continue. Inverse of matrix, and we are going to concentrate on 2 by 2 matrix. That's what we are going to be concentrating on at this point. Is that okay? Now if A is a matrix, okay, so if A is a matrix, then the inverse of A is denoted by A raised to power -1. Okay, so when you see something like this, that's what we call the inverse matrix, A raised to power -1. All right, so if our inverse matrix is denoted with this, then how do we go about solving inverse matrices? All right, so if the A we are talking about, if A, that A is given as E, F, G, H, all right, then what will be the inverse? The inverse, A complement A raised to power -1, will be equal to, you are going to find the inverse of the determinant of A. Okay, the inverse, that is 1 over determinant of the matrix given to us, which is A, then multiplied by, now at this point please pay attention, you are going to interchange this element of this matrix, this in diagonal way like this. So instead of writing E now, we are going to replace it with H. Then instead of writing H, we are going to replace it with E. So we interchange them diagonally that way. And then these two other elements, F and G, we are going to change their signs. Now they are positive, but we are going to change it to negative. That's how we roll in inverse matrix. Is that okay? So here now we have H, this F become -F, then this G become -G, and instead of writing H now we put E here. Okay, so now we have successfully found the inverse of matrix A this way. All right, so for you to understand it better, we are going to take a look at some examples. Is that okay? Examples now. So the first question here says find the inverse of the following matrices, So the first one says 6, 3, 1, 2. Then we are going to be finding for this also 5, 3, 2, 3. And then number 3 is 1 over 6. Then 0 minus 3, 20. Okay, solution. Now for this first one, we are having 6, 3, 1 and 2. Now is equal to, now let's quickly go back and then I will show you something. So this is the formula we are going to be following in order to find the inverse of all those matrices given to us. So to find those inverse, the inverse of those matrices, you are going to first of all find the determinants. Then you multiply it with the interchange and then changing of the signs of the elements of that particular matrix. Is that okay? So let's continue. Now it's going to be 1 divided by the determinant of this matrix. We have learned how to find the determinant of a matrix. So we are going to multiply diagonally and subtract the answers from each other. Okay, determinant of this is going to be 6 multiplied by 2. So 6 times 2 will give us 12. Then minus, then we multiply 3 and 1 together diagonally. 3 times 1 is 3. Then multiply by, then we interchange these numbers diagonally. So instead of writing 6 here, we put 2 here. Then here we put 6. Then this plus 3 we change to minus 3. And then this plus 1 we change to minus 1. As simple as that. Okay, so if you solve further, we have 1 over 12 minus 3 will give us what? Will give us 9. Then 9 multiplied by 2 minus 3 minus 1 and 6. So this is our answer to this first question. So this is the inverse of the first matrix given to us. Well, you can still do it further, okay, and do the scalar multiplication. All right, if you want to do it further, then you will have 1 over 9 times 2. That will be 2 over 9. Then 1 over 9 times minus 3. That will be minus 3 over 9. And this one, you know that you can still reduce it to 1 over 3 actually. But let's multiply further. Then 1 over 9 times minus 1 will give us minus 1 over 9. Then 1 over 9 times 6 will give us 6 over 9. Understood? So if you split, work on this further, you have 2 over 9, then minus 1 over 3, then minus 1 over 9, then 3 goes in 6 2 times, over 3 goes in 9 3 times. All right, so if you have to work on it further, this will be your final answer. But sometimes you can also stop your answer at this point. You are also correct. But if it is in objective and you are not seeing your answer to be this, then you will find your answer to be this. Is that understood? All right, so let's continue. The next question we are going to be tackling says 5 3 2 and 3. Okay, so we want to find the inverse, and the formula is 1 over determinant of this matrix. And the determinant of this matrix is multiply this 5 and 3 together. 5 times 3 is 15, minus, then multiply 2 and 3 together. 2 times 3 is 6. Then multiply by, then you exchange these numbers, these diagonal numbers. You interchange, then you have 3 and 5. Then this 3 change it to minus 3, and this to minus 2. As simple as that. So we now have 1 over 15 minus 6 will give us 9. Okay, then minus 3 minus 3 minus 2 5. All right, so you can leave your answer this way, or you solve it further like I have said, and that would be 3 over 9, then minus 3 over 9, then 1 over 9 times minus 2, that will be minus 2 over 9. Then 1 over 9 times 5 will be 5 over 9. Okay, so if you work on it further, you have 3 goes in 3 one time, 3 goes in 9 3 times, then minus 2 over 9, then minus 1 over 9, and 5 over 9. Okay, So if it is subjective question, they can stop it here or here. All right, so that is that about that. And finally, let's take a look at the third one, and which is 1 over 6 into 0 minus 3, then 2, 0. So when you are given this type of question and you are told to find the inverse, so there's no cause for alarm. See, since you're having a scalar here, it means this scalar you're having here is 1 over your determinant. So the determinant is 6 already. All right. So what you just need to do is to interchange these numbers. So here, luckily for us, we're having 0, 0. So nothing to interchange. But this minus 3 will change to plus, and this plus 2 will change to minus. So, and that would be our answer. So we have 0, then 3, minus 2, 0. So that is the inverse of this particular matrix. I hope at this point you've understood how to solve problems under transpose of matrices and inverse of matrices. Alright, so this is where we are going to be ending today's class. Thank you for watching. Bye.